So we're ordering some roses. It says for what number of roses is it less expensive to order from florist A and then from florist B? So first we need to write some kind of algebraic statement, right? So florist A is 475 R for rose, and then $40 delivery charge. And then the other florist is 515 R plus 25 delivery charge. So you can kind of say, well, why would you ever order from florist B? Maybe if you just glance at this, because they charge more per rose. But their delivery fee is $15 less, so that kind of makes up for some of it, right? Why did I leave it? What in between these two? What should I put? Let me ask it that way. Inequality. And so it says for what number of roses is it less? So we'll start with A having the less than sign. Okay. Probably nice to have a calculator perhaps here. What's a good way to solve this?
I would get started with I would subtract 40.
Okay, he wants to subtract 40.
All right, no, don't do it.
Okay. You got overruled. By the way, subtracting 40 would have been fine. It's not the best way, but it works. So what else can we do, Jack? Sure.
I would find out how much more.
I wouldn't do that. I want to do it algebraically. Yeah, let's do it algebraically. Go ahead, Luis.
You would subtract 475 R and from your side.
All right, so that is 0.40 R plus 25. Okay, now what? Process-wise, this is just solving an equation, right? So I think at this point, I hope you haven't forgotten what we've done with that, because the next thing we want to get R by itself. So what do we need to do? Not yet. We need to get R by itself, so we're going to get rid of the 25. Now we can divide. Do we need to flip the inequality? No. Did we divide by a negative? Nope. All right, 15 divided by 0.4. Let's do that. 15 divided by 0.4 is 37.5. Okay. What does it mean? 37.5 what, and what does it mean?
It is less than R.
No, I don't want you to just tell me what that says. I want you to explain what it means in the story. Derek, what does this number mean to Derek? Diego, how about you?
Oh, wait.
Well, you got to be a little more specific. Yeah, try it, Jackson.
If he orders more than 37 roses, then florist B is better. Or
Florist A. So you started us off good. Please write this on your papers, everybody. If Derek orders more than 37.5 roses,
but you can't order half rose.
florist A is cheaper. Okay, why does it say that? Like all I see is R is greater than 37.5. So how in the world did we get this whole pink narrative from R is greater than 37.5? Thoughts? How do we get that? At a minimum, you need to know that R is roses, right? But what happened here? There it goes. Go back to our original setup. This. What did we set this up to say? Can you pay attention instead of distract? What did we set the original inequality up to say? Pick it up.
A was less than.
Yeah. Florist A is less than florist B. That's what we initially set this up. So when we go solve through, the R is a count of roses that make that happen. Okay? Guys, the interpretation part is why we do the math. Understand this answer is useless without understanding what it means. And so why do the problem if you don't? That's true of in-context problems. We've got to know what they mean and what they're telling us. Okay, the problem goes on to say from florist B, and so we could flip that around and switch our inequality, but we know it would be less than 37.5 roses for the other company to be cheaper. So we don't really need to solve the whole thing twice, if you know what it tells you. Okay, grab your homework. Let's go ahead and check that. Starting, we just had 4 problems. We can do any of these that you want to, but number 25, you should have solved. That one had fractions, so it was a good review of solving with fractions. Should have got x is greater than 16. That is an open circle pointing to the right. X is greater than 16. Number from there, 29. You should have chosen B. I'll go show you what that actually says, but should have chosen B. Okay, then we went clear to 43. 43, fill in the circle to represent the x is less than or equal to 12. And then 45 was after 3 hours, Aisha was going to catch up and be in front of Luke. So, any of those that were confusing that you would like me to do? Yep.
29.
All right, 29. Yep. Mm-hmm. With lots of work, I'm sure. All right, which one did you say?
29.
29. All right. So match each inequality, not for just writing answers down. Match each inequality to the graph that represents its solution. Explain your reasoning. Okay. We do have a little bit of work to do to solve this. Do you see that? So we need to distribute the negative 2, and get x by itself is really the goal here. Let me put this where I can write on it. Hold on 1 second. This will take 5 seconds. So distribute, let's don't use the highlighter. We'll get negative 6x plus 2. Okay, now what? We're just solving an inequality. What do we do next? Yeah, Jeremiah.
Add 2 or subtract 2.
Yeah, you got it. Okay, if we subtract 2 from 20, let me get this in the right way. We're going to get 18. Now what? This is the critical step right here. What are we about to do to get x by itself?
Divide by -6.
by a negative, right?
Switch it around.
So x and then switch and negative 3. So which of these says x is less than negative 3?
B.
B, yeah. Sure, go ahead.
I thought that I messed up because I thought that you had to flip it if it was like with the distributive property where you multiplied it by -2. But
Nope. Only, okay, so I'm glad you brought that up. Here's what he said. Everybody look here, please. Right here, we did a negative multiplication, and we got -6. But that didn't travel or go across the inequality symbol. That's when we have to change it. So it's only if it's across and happens on both sides. Thanks for bringing that up. That's a good point. All right, anything else you'd like to talk about on this homework problem set? Yeah.
45.
Okay, 45. Luke and Aisha are traveling on the same road in the same direction. Luke is driving at a rate of 50 miles an hour. And Aisha is driving at a rate of 55. Write and solve an inequality to find when Aisha will be ahead of Luke. Here's what we're trying to solve for. How much room do I have over here? We are trying to find where Aisha is ahead of Luke. So at a very minimum, am I zoomed out all the way? Yeah. All right, I'm going to have to write that somewhere else. Give me a second to do that. We are solving this. Where is Aisha ahead of Luke? Now we just need an expression for each of them. And Aisha is 55 miles per hour. Or you could do it just 55h, 55x, whichever one you want. And Luke is 50h. But what do we have to add on him based on this picture? So he's 15 ahead already, right? He's had a head start, maybe we could say. So we add the 15, and now we solve. It's really 2 steps. So subtract 50h, and we'll get 5h. And then divide by your 5, and you get 3. Did we need to flip that around at all? Okay, and this is hours. So after 3 hours, Aisha will be ahead. What happens at 3 hours? They meet, or they're like neck and neck, right? They're next to each other. Did that help, Maria?
Oh, yeah.
Okay. Yeah, absolutely. All right, cool. We are going to extend the concept of inequalities now. So grab your note packets. Curious if you have seen this next topic, which is called compound inequalities. And you might have seen them before. Here's what one looks like, just in a very basic form. Maybe it says something like this. We've seen it when we're doing interval notation. That would be kind of a solution to a compound inequality. So if we just add stuff in here to make this more complicated, like maybe we say 2x plus 3 in there, and now we have to solve. That's kind of getting to where we're thinking. Or maybe we add some x's on the sides, etc. So that's what we're calling a compound inequality. It's when we have the x in between two different things. Or another version of this is like x is greater or equal to 5, x is less than -2. And so it's like splitting. It's not in between, but on the outsides of. Okay, so just a quick reminder. I'm going to take this off. We'll see it in a second. If we graphed this on a number line, what would it look like? This first one on the left. Well, hopefully we know we need to at least write 5 and 10.
Yeah.
Okay, and then what?
Equal circle go to
Close circle on the 5.
8 and 9 and then
Open circle on the 10. And so we're talking about all values in between there. Okay? How about over here? How does it look? So remember to read your inequalities first. Yep, Jeremiah.
Two separate lines.
Okay, I'm going to put -2 here. Tell me what's going on with that one.
X
Open.
is smaller than it, so it's going
Pointing left. And I'll stick the 5 up here. Stick a 0 somewhere in between. Okay, what about the 5? Closed, pointing right. Okay? So this is the two different scenarios of a compound inequality. That our solution may end up saying, hey, it's all values in between here. Or it's all values outside of here, which is the second case. Everybody kind of seeing the difference in what we might have. Okay? Both of these come up in real life, by the way. Here's just, we're not going to take time to like work through this whole problem. Let me turn this so you can see it better. But let's think through this scenario. It says Hannah has some blue paint. She wants to lighten the shade. So anybody who's ever done paint or maybe even like pastels, like chalk or oil pastels has done this. So she's going to mix in a cup of white paint. The color is still too dark. So she keeps mixing in a cup of white paint at a time. Everybody seeing this in your mind's eye? After adding 4 cups, she decides the color is now too light. Oops. Okay. Explain in words how much paint Hannah should have added initially to get the shade she wants. So thinking back to what I just showed you, which of these cases is it? You can just say like left or right or something. Okay? Does everybody see that it's the left one?
Yeah.
1 was too little, 4 was too much, so we're somewhere in between. Okay? All right, so that kind of illustrates that. We're going to use these. These are actually, surprisingly, these are important mathematical words. One of them is the word or, and the other word is the word and. And it's kind of interesting that those basic words mean something in math, but they do. So, or is this case, the split one. Can you kind of see why it might use the word or? It's either, we could write it out in kind of sort of English, either x is less than -3, less than or equal to, or x is greater than 2. So in English, that's kind of why we say it's the or case, because it's two separate pieces. It's not overlapping or joining together. Okay, here's the and case. Yep. Notice it's the one where the values are all in between. Can you guys tell me up here I just wrote the quote marks, either x is, etc. Can you tell me what the quote would be for this one, the English version of what this inequality says? It might help if you look down here at this one, like these two. Yeah.
4 is less than or equal to x, and 1 is greater than x.
Yeah, that's kind of it. Tell me, you're saying it correctly, but it's a little bit unclear. Let's say it that way. What would be the inequality for this first one right here? What is the inequality for that? X is greater than 4 or equal to 4. How about the bottom one?
X is less
I should have said negative 4, sorry. X is less than 1. Do you see how there's overlap here? That section overlaps. And where they overlap is the only part that's true. Because if I have to meet both of these at once, I can't, like this part over here doesn't work. It's above 1. And this part down here doesn't work. It's below negative 4. And we have to be between those. So X is kind of like what Caleb said. Greater than or equal to negative 4. Stupid fly is getting on me. And less than 1. Okay. In your own words, in your head, I want you, so no talking. I want you to describe the difference between or and then you're going to tell somebody about it. Okay? So in your own words, what's the difference between... Okay, in your own words, JC, what is the difference between and or? Well, that's a problem. What did people tell you?
Jackson said and was equal to or less than 1. I did not. Yes, you did.
I mean, I can try to fit both of these on here. You can see them at the same time. You can see the picture. Aliana, what'd you say? I'll get you, Levi. Okay, so we had that word either, Levi.
And is like a continuation, it's like the same kind of loop, continuation of it.
Okay.
Or is like separated, two different ones.
Okay. Or is separated and is together.
Or is two separate pieces which go
JC,
on
look up here while he's talking.
in alternate directions, and there are no numbers in between the two numbers that are equal to x. And
Okay.
and is one conjoined piece, which connects two numbers, and everything in between is x.
Perfect. Jack, good job.
I like to
Caleb.
think of it as like two buttons labeled A and B. For and, you have to press A and B to make a light shine. And it has to be both at the same time. But if it's or, then you have to press either A or B. But if you press both, then it won't make the light shine.
Okay, that's awesome. Shining lights with buttons. Nice job.
Oh, that's how those sensors work.
All right. Yeah, good job. Okay, so I'm going to just pick on random people, not pick on, but pick random people to answer a simple question, which is it and or is it or? So there's lots of these, so be ready because there's probably enough to get most of you. Okay? Just based on picture. JC, what is this one? And because it's between two, right? It's above negative 1 and it's below 3 at the same time. All right, Aliana, that one. And good. Hudson, how about that one? It's kind of a trick question because it's just the one, right? Is this a compound inequality?
No.
No, not a compound inequality. Who are you telling chill? Hudson, I kind of tricked you on that one, so good try. 26. Arissa, tell me about that one. It's not compound, good. Because it's just going one direction. It's just the usual. All right, how about this one? Let's go to Jack.
Or.
Why is it or?
Because it's two separate things and they're not connected.
Yeah, barely, right?
Yeah. That's pressing either of the buttons.
All right. How about this one to Declan?
I think it's R.
Or. O-R. Okay. All right. JC, back to you.
I don't know. Or,
Why?
because there's, like,
Okay, here's the big idea. If you can't meet the criteria for both at the same time, it is or. Here's what I mean. I am going to pick a value of -4 right here. Can I be less than -2 and greater than 3 at the same time? No. If you can't be in both places at once, it's or. If you can, it's and that's kind of the simple version of it. So let's go write that down in your notes, please, in here. We're just going to write it in boxes in the note box. Probably don't need to talk so much while you're getting ready to write stuff. That means you're not thinking about it. And then you end up not knowing it. Okay?
Let's tone it down a bit.
Okay, compound inequalities. We have two versions. So let's start with the and version.
All right.
X values can meet both inequalities at once.
Okay.
Why are we doing that? That's annoying.
No, that wasn't even me.
Knock it off.
Sir, yes, sir.
Okay, I don't need to put that there. Here's the version of a graph.
at once or at one.
At once. It can meet both inequalities at once. Okay? So over here where x is greater than or equal to -4, x is less than or equal to 5. Any value in between is true for both of those. It's actually, let's write it out and make that super obvious. Maybe that for both. Here's why. It's greater than -4 and less than 5. That's where we get our and from, is because it's doing both at the same time. Okay, just kind of pausing for you to catch up if you need to. I guess before we do that, let's go add the actual inequality to this, which would be this. Kind of mirrors the graph a little bit. X is in between two numbers. All right. For the OR case, x values can meet only one inequality at a time. Or in other words, cannot be both at once. So let's make up one of these. Actually, I'm going to choose to use the same numbers. Let me fix that. So -4, +5. And we're going opposite directions this time. So x is less than or equal to -4. X is greater than or equal to +5. Okay, here's the big idea. A value cannot be less than -4 at the same time as greater than 5. Do you agree? You can't be smaller than -4 but bigger than 5 at the same time?
Yes.
Okay, so it's either or. There's kind of the concept behind that. It's either going to be one or the other, but can't be both at once. So how do we solve these? That's the next question that we will tackle tomorrow. No homework tonight. But except for if you probably should start looking over stuff we've done, just keeping it fresh, okay? All right, have a good day.